Right, since I had so much fun yesterday and there's been a bit of interest and there's also heaps of interesting weather going on at the moment, I thought I would do another weather discussion. So here we go, lots of activity in the tropics, and you might notice this standout, Typhoon Kammuri is about to hit the Philippines, and in the south we've got fronts coming through, and we'll have a look at that as well. But let's have a look at this cyclone first. So I don't know how well the internet's going to work, but yeah, this is pretty serious. I don't remember what category it is, but it's probably Cat 5. It's pretty intense, so let's see if this thing spins up. Yeah, you can see the rotation there. It's in the northern hemisphere, so it's anti-clockwise, and yeah, cyclones have to be about 10 degrees away from the equator as a rule of thumb to have a weak Coriolis force that helps organise it into a cyclone. And one of the main ingredients they need is deep level moisture and no winds breaking it apart. And if you look at, we'll have a look at that in a sec, but yeah, warm ocean is what it's feeding from, getting all its energy from latent heat. So that's the infrared, and then the enhanced shows it's really red up there. So let's see if we can figure out how cold it is. 195, 273 Kelvin is 0 degrees, so you're looking at about 80 degrees colder than 0, so about minus 80, so that's pretty cold up there. And maybe even colder over here. Probably not too much different. Yeah, anyway. So if we have a look at the weather model sounding, which is a profile of the atmosphere as it goes up, you can see that these lines, red is the temperature and blue is the dew point, are basically touching, which means that it's 100% humidity or close to all the way up. And you can see the winds are pretty much blowing the same way all the way up. This only goes up to 14,000 meters. Normally the top of the atmosphere is nominally 11,000 meters, like that's the standard they use. Obviously it's different in nature, but in the tropics it's always a bit higher, and I don't even know how high it is up here because we've got minus 60 degrees. We've measured minus 80 degrees on the top, so I guess the troposphere, where it starts getting warmer again, is off the charts at the moment. And if we click on the other side of the cyclone, obviously the winds are going in another direction as they're going around, and it's just really deep convection. It's not like well, what we'll show you in a moment, that this is just winds going all the way up through the atmosphere, humidity going all the way up through the atmosphere. That is a lot of energy, and the temperature at the surface is, looks like it's pretty close to 30 degrees. Actually, we might even be able to get that off windy. It's just amazing how much information there is on here. Sea temperature. I can't remember what the rule of thumb is for how warm the sea needs to be for cyclones, but yeah, obviously 29 degrees is warm enough. So here's the BOM satellite imagery for Australia. It's a bit of an annoying interface because it doesn't update and it doesn't have as many features as Windy, but it does look nice. So this is the visible imagery, and yeah, try to look at the satellite picture first and figure out what kind of weather we have. So the visible imagery shows you the cloud, but it doesn't show you the heights of the cloud, but try and guess how high the clouds are. So over here, this stuff, you can see it's sort of wispy as it drifts off downwind. That's cirrus, that's real, well, we're seeing the tops. So it's really high on the tops there. And like I talked about yesterday, you've got some broad scale upslide where the cloud just starts forming here, but there was moisture in the air, it was just water vapor further up, but when it got finally lifted to the dew point, it started forming the cloud. So that's all coming down and wrapping around, and if you look at the, this is a 4-hour loop, so you can see a bit of movement, and you see there's some rotation around here. That's a low pressure system. There's also another one over here, and all this air you can see is slowly moving up from the south, so that's why it's got that unstable look about it with all those cumulus clouds. It's cold air moving over a relatively warm ocean because it's just warmer as you get towards the equator. You can see that as it hits Tasmania, like there's more cloud on the west, there'll be some more rain on the west. I can actually show you the rain. This is in the last hour, there's been some rain in the west, some showers through here, and also showers on the west side of the Great Dividing Range, because that's where the weather's coming from. I probably shouldn't have given that away, but if you look really carefully, I won't zoom in now, but there's actually little wave clouds in there because of all the topography, and so those clouds are just sitting there, staying in the same place, and there's like bands of them coming back. So obviously some pretty strong winds down there. Over here, this cloud looks quite different to this cloud. This cloud looks a lot more like bumpy, and it is, like these clouds go much higher, they're high enough to produce rainfall as we saw before, but these clouds are, they kind of look really funny. And if you can just imagine if you had some bumpy clouds and then you just put like a glass sheet on top of them and just compress them down so they're really flat, that's what these clouds are. So there's a really solid inversion over here, and the tops of these clouds, like if you're in an aeroplane and you descended until you hit the clouds, you'd be looking out over a very flat sea of clouds, whereas this one here is a lot more bumpy. Also, we've got some beautiful gravity waves. You see this dry influence sort of pushing out and influencing these clouds over here. That is no doubt from a day or two ago with storms over here, and then you get these really strong gravity waves where basically the storms dump down all their rain and it's just sort of like dropping a rock in a pond, and the ripples just keep going out for days out into the, like in the tropics, nothing really much happens. You don't have all these fronts organising all the air with the Coriolis because it's further away from the equator. So any disturbance can just travel for days and days. What else was I going to talk about there? So yeah, I said there's lots of cold air coming up through here. I mentioned the gravity waves. You can see the sun glint, although it's just about off the picture. There it comes. So that's where the sun's shining directly at the water, tracking across Australia in the tropics. And there's a bit of build up in the top end. You can just see some storms developing over here. So on that, let's go to the lightning. There's one thing I actually wanted to talk about that I forgot, but when these clouds are over the water, they're quite like big, and when they go over the land, they're a lot smaller, and it's really because there's more intense heating over the land. So over the water, the clouds are building really slowly and it's all really broad, and so you get big clouds. But the surface heating on the land is, because the land can heat up a lot hotter, it doesn't have to just use all the energy to evaporate the water. You can get, you know, like just stronger thermals and smaller clouds because it doesn't need such a big area of slowly heating stuff to form clouds. Right, so I was going to talk about the big influence the land has on clouds, and if the land is drier, and if you've cut down all the trees and say you cut down the rainforest, it's going to obviously have a lot of effect on the weather in the local area. And a lot of the moisture actually in rainforests is like the cloud cover. Normally rainforests sort of produce their own cloud cover because there's so much evaporation from them. But when you have a dry desert here and you pass this moisture over it, it really just changes the airmass quite significantly. Right. So lightning, we've got some lightning here, and I'll just talk a little bit about what kind of lightning this is. I guess these ones here are kind of being brought down in this broad scale upslope flow, and so are these, but maybe back here you couldn't really say that because these ones are kind of moving, or maybe they're moving from the west, but you could almost say they're moving a little bit from the southwest. But here, yeah, for sure, they've got more of a northwesterly direction that they're coming from. So that might be to do with that broad scale upslope flow that I was talking about before. So back to windy. Yeah, if we look at the what I was going to do is show some temperature traces like we did with the Typhoon for these different areas that we're looking at. So if we go to here where the gravity waves were, you can see that you've got, you know, a fairly dry air mass because these lines are quite far apart. Obviously there's not a lot of cloud out there, so that makes sense. But down the bottom, the temperature just dips down, and that's basically a maritime inversion. If we went over the land, you can see there's no maritime inversion. The sun's heating the land and it's getting, you know, high 30s Celsius, and there's a lot of heat there and it's very dry. But when that passes over the water, you get that cooler influence underneath. So basically this is what we call an inversion, where the temperature increases, and that's basically a stable influence. So unstable things, if you push them, they sort of wobble and fall over. But a stable thing, if you push it, it goes back to where it is. So if you drop a pond on this inversion, we have like a big storm that drops all this rain, and then things bounce up and down. Then you get these gravity waves just travelling for thousands of kilometres, bouncing on this inversion. So down here, I was talking about it being like pushed under a glass ceiling kind of thing. I'll just have to move this a little bit. So yeah, you can see that there's a pretty strong inversion there. There's like moisture right down the bottom, really low level moisture where the clouds are forming, but above that it's very dry. So that's how I describe it, that everything is very warm, dry air on top of a low level cloud cover. Now over here, we didn't see any lightning in this part. It's a little bit hard to see with these windy soundings sometimes, but basically this line here, I'm not sure if this is a very good example, but basically there's a lot of moisture through the trace, and it's not producing lightning at the moment. There's probably just not enough moisture, and it's not unstable enough. But if we go over to here, you can see that it's unstable because this red line is leaning to the left of this one. So if you get a parcel of air and lift it, it cools at the rate of this grey line here. And because the actual temperature around it is colder than that, the hot air rising is still going to be hotter than the air next to it, so it's going to keep going up. So then you'll get a storm. And that just goes right up, like, oh, we're looking at the zoomed into the lower level, but yeah, 9,000 meters. So that's where the tropopause is. That's like the top of the atmosphere where all the weather is. After that, it dries out. And yeah, so the tops of your storm clouds are going to be around 9,000 meters, which is considerably lower than whatever it was at that typhoon, which was well over 14,000 meters. So yeah, nice unstable trace there. There's no inversions to break through, and you can get parcels there being lifted all the way up to produce storms. And probably I can just look at the, what else was I going to show you? Oh, so yeah, let's have a look at the wind, and then we can confirm what the synoptic chart looks like. So that's the wind, and if you click this little one down here, the synoptic chart. So this is a high pressure system. High pressure systems are associated with like large areas of sinking air. The reason that there's high pressure there is because on the surface there's like more air on top of it, so the air is coming from around, and sort of in the upper levels it's all coming together, and it's getting like squished. So that means that there's more air in that area and it's pushing down, so all the air is sinking, and as it sinks it warms. Rising air cools and sinking air warms, and then it just sort of presses down on that low level moisture underneath to get those clouds. And here we've got those two low pressure systems that we saw with the movement of the clouds and the satellite. And yeah, because there's, you know, these are quite low lows and this is quite a high high, so we've got really strong winds through here, which were producing those little wave clouds we saw over here, and the westerlies are bringing some rain to the western side of the Great Dividing Range. And that's probably enough to talk about for now. Another interesting day with the weather.